So this is going to be a shortcut for graphing sine and cos when you have A, B, C, and D. We could do it the same way as transformations, going left to right, starting with A, then B, then C, then D. But it'll be faster to use this technique that I call DAB-C. So very first thing, whatever your D value is, that will always be your sinusoidal axis. Your A was your amplitude. Amplitude is the distance from your center line or sinusoidal axis to a maximum or to a minimum, so we can use our amplitude.
All international students, please report to the library. That's all international students, please report to the library.
So we can use the A value to label our maximum and minimum values. Next, our B value is related to our period. So we use the B value to calculate the period, which we figured out with the formula yesterday, that your period is always 2 pi divided by your B value. We're going to label that period on our x-axis and divide it into 4 equal sections to represent the axis family. In the DAB-C technique, the dash in the DAB-C actually means something. The dash means you will graph without the phase shift with a dotted line or a dashed line. So it actually stands for draw your graph with no phase shift with a dashed line. And finally, the C value, you're going to translate your graph, that dashed line, either left and right, depending on what kind of horizontal translation you have or phase shift that you have. I'll have to write that part yet, that's for the next question. Here we are, we're back. So we're going to look at how
How am I supposed to get back into this?
we can use the DAB-C to graph this quickly. So you get a question, you have to graph y equals 3 cos 2x minus pi over 4 plus 1. It's already in factored form, that's going to be important just like before. And the first thing we're going to draw on here is the D value is 1. That is your sinusoidal axis. I like to take out a red pen and I like to draw my sinusoidal axis, the dotted line, label it, it's at y equals 1. That's your average, that's your sinusoidal axis. And so at this point, I'm going to put a check mark above the D, because that's all you have to do in DAB-C for the D value.
Is that a 4 or a 9 in the?
That's a 4. Yeah, here, I'll make it nicer. Next, we use our A value. Our A value is our amplitude. Amplitude is the distance from your sinusoidal axis to a maximum or a minimum. So all we're going to do with the A value is go up 3 and label that height as 4, go down 3, and we're going to label 4 and the minus 2. That's all we have to do for our amplitude. I'm going to put a check mark. The B value is connected to your period. You have a formula, I've got it above there in green. Your period is always 2 pi divided by your B value. So our period is pi. The B is probably the biggest thing to do because what you have to first calculate the period, then randomly make a mark somewhere along your x-axis and label that with your period and then divide that into 4 equal sections. And we're going to label all 4 of these sections. So if my period is pi, the next one that I always label is the middle one because it's easy to figure out. If this is pi and this is cut in half, would you agree that this is half of that, which would be pi over 2? Then I label the first one. Because if this is pi over 2 and I cut that in half, I would get pi over 4. And if one of these sections is pi over 4, you can label the third one by just counting. 1 pi over 4, 2 pi over 4, this will be 3 pi over 4s. And then I can put a check mark over the B. I've done the B part of DAB C. The B part, again, it's the biggest one, so I'm going to say it again. What did we do? We figured out the period by using the formula. Your period is always 2 pi over your B value. We labeled that period and then divided it into 4 equal sections. Easy to label the middle one first, then the first one next. And once you have the first one, the third one will just be 3 of the first one. So I do 3 pi over 4s to get the third one. Next is the dash. So what you do is you say, what kind of graph do I have? I have a positive cos graph. You have to know what your cos graph looks like. Cos graphs always start at a maximum. Sine graph starts in the middle going up. So cos graph starts in the maximum. Your 4 equal sections will always mean you go maximum, then middle, then minimum, then back to the middle, then back to the maximum. With a dotted line, draw your cos graph. That is the dash part of DAB C. And finally, we have the shift. The shift says minus pi over 4, that's pi over 4 to the right. We take each of these points that we have, and pi over 4 to the right is pi over 4 is labeled. So you see it would be 1 section to the right. So this maximum moves 1 section to the right. This one moves 1 section to the right. 1 section to the right. Well, this one moves 1 section to the right, and this one would move 1 section to the right. Put arrowheads on the end, and this is our final graph without having to do any mental math. If you used your old technique from transformations, you would have to say, I recognize my original function is a cos graph, right? And we drew these graphs the other day. This is my cos graph. It starts at a maximum, then center line, then minimum, then center line, then maximum. And you would have to take all 5 of these points. 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi 1. And do all the mental math with pi's and multiplying and subtracting and all of that to get the answer. In the shortcut method, you just label your x and y axes and your points get labeled automatically. For example, this point down here happens to be at 3 pi over 4 comma negative 2. It probably would not be very fun to do the mental math to get to that point with multiplying, adding, and subtracting. It is much shorter if we can do it directly with the DAB C. Okay, let's do another practice one with DAB C, and then we'll get to example 1. So again, I'm going to write off to the side as a reminder, so I can do one section at a time. Dab C. And sometimes you're going to use your D and your A values together to sort of get a sense of how you want to draw your axes. Normally when you draw axes, you draw it perfectly in the center. But for this one, I'm going to look at this and I'm going to say, okay, can I see my center lines at -2? So I'm going to draw my line a little bit higher. So when I draw my center line, I have room above it and below it. Does that kind of make sense? And that's all I have to do for D. I look at my A value, which is a -4. So the negative is going to have a reflection, but the amplitude is always a positive number. Our amplitude is 4, even though there's a negative in front of it. Amplitude is the distance from a center line to a maximum. So with an amplitude of 4, does it make sense that my maximum is going to be here at 2? And if I go down 4, 1, 2, 3, 4, I'm going to have a minimum at -6. That's what the A value in DABC does. It allows you to use your amplitude to find the maximum and find the minimum. Next, the B value, which is probably the most intense of the DABC. You have to use your period formula. Your period is always 2 pi divided by your B value, and my B value is 3. I randomly pick a spot on my x-axis and label that as 2 pi over 3. And then I cut that in half and cut each of those in half to divide it into 4 equal sections. What is half of 2 pi over 3?
Pi over 3.
Pi over 3. What is half of pi over 3?
Pi over 6.
Pi over 6. Right? Because half of pi over 3 is just like multiplying pi over 3 times a half. How do you multiply fractions? Multiply the tops, multiply the bottoms. And if that's pi over 6, the third one will be 3 pi over 6's. And it is okay if you write it as 3 pi over 6. It is also okay if you reduce that to pi over 2. I'm writing it as 3 pi over 6 right now, so you really can see I just counted 3 of those spaces. If one of the spaces was pi over 6, 3 of those spaces would be 3 pi over 6. But you could reduce that to pi over 2. And that is your B value. B value, we have to find out what the actual period is, draw that on our x-axis, and divide it into 4 equal sections. Now, when we're doing this for sine and cosine graphs, you're going to hear me say cosine graphs start at a maximum, sine graphs start in the middle, going up. Does it make sense that a negative cosine graph wouldn't start at a maximum? The negative with the reflection would start at a minimum. And a negative sine graph is going to start in the middle. So here's my middle point. I'm going to draw right there's my starting point, but middle going down. A regular sine graph is the middle going up. A negative sine graph is the middle going down. Next ticking mark, I'm at my minimum. Next ticking mark, back at the center line. Next ticking mark, I don't know if that's what they're actually called. I won't go with that. And the final ticking mark back at the center. So it's going to go with the dotted line. This is without the shift. And finally, which way do we need to shift it? Okay, I forgot, check mark, I did the dash. There we go. Finally, which way do we need to shift it? Pi over 6 to the left. Does my scale have pi over 6 on it? Yes. Does it make sense that if I go this exact same distance, this would be negative pi over 6? And each of my points, which I'm going to do in purple, is going to move 1 ticking mark to the left then. This one's going to go here. This one is going to go there. This one here, This one to the left, and this one to the left. Okay. Course is particular. I'm going to show you how you can lose a half a mark. Don't write this down. There we go. That would lose a half a mark because these are very pointy. Sine and cosine graph is nice flowing curves. So I lose a half mark, too pointy. Erase that. Go rounded through that one. Rounded through that one. There we go. Doesn't look much different, but it can't be a pointy, sharp point. It's got to be rounded at the maximum and the minimum. Okay. I mean, there's lots of ways to lose marks on graphing. I mean, I'll do. If you do things fast and you're sloppy, like, woohoo, oh my goodness, whoa, that's gonna lose you marks. You're like, whoa, I went way too fast through there. I gotta come back through this point. This is no longer a function because it doesn't pass the vertical line test. It looks, yeah, I got that's scary. Better erase that. So take your time, draw things smooth and nicely, color code things, and we have completed the C. So we are ready to do example 1. So in part A, it says predict. Predict won't be a word that you'll see on the exam. On the exam, they would probably use describe. And if it was describe, we'd have to use full sentences and words. I'm going to take advantage of the fact that they didn't use describe, they used predict, so I'm going to shorthand it to make things quicker. What does this 1/4 do? Okay. In transformations, you could say that this 1/4 is a vertical compression. In this unit, we also talked about being the amplitude. So when you went to describe it, you could say the amplitude is 1/4. You could also describe it as a vertical compression. The y is going to get multiplied by a factor of 1/4. Same thing for this next one. Inside is going to be horizontal. It's going to be a horizontal compression because x's are liars. You multiply by 1/3. You could also in this unit describe this one as the period is equal to 2 pi over 3. Okay, the pi over 6, that's going to be a horizontal translation. Sometimes in this unit they talk about phase shift. I don't know where they come up with these words, but it's another thing moving things left and right. Okay, so that one I'm only going to write the blue part. And this last one, this is a vertical translation to up. In this unit, we talk about the sinusoidal axis being the d value. If you were asked to describe this on the exam, you could use the transformation language, or you could use the language of amplitudes and sinusoidal language. Both would be fine. You would get to choose. You could say both if you wanted to be really, really clear on a described question, but it said predict. So I'm just going to write down the shorthand letters. I lose marks for that if it was a described question because I didn't use big words, sentences. Okay, so then part B. Part B, we're going to use our DAB C. Okay, and we are going to, I'm going to put, most likely the exam will not say like this. On my tests, for my tests, I'm going to say for at least one period, but I'll talk about that highlighted part at the end in case something like that comes up and how not to lose marks. But that yellow part actually extremely annoying. So for at least one period, you will not be as annoyed. And we'll see what that looks like. So we're going to do the DAB-C. Well, just looking at my D value is 2. My amplitude is 1/4. So when I go to start drawing this, it's not going to go into the negatives at all. It's going to, right here, have my sinusoidal axis at y equals 2. That's all I have to do for my D value. And if that's 2, my amplitude is 0.25. 1/4. Does that make sense that our maximum now is here at 2.25? And my minimum would be at 1.75. It's going to be a very skinny cosine graph. But that is enough to do our amplitude. Our period. Our formula for a period, we already figured it out here when we were describing. Our period is 2 pi divided by 3. So I go along my x-axis here. And I mark a spot. Yeah, I'm going to just mark it right there. Anywhere and mark 2 pi over 3. Okay. Oh, yeah, what they asked us to do is the highlighted part, you're going to see in the end, super annoying. But right now, we're going to do what I said instead, at least one period. Mark it as 2 pi over 3, divide it into 4 equal sections. Half of 2 pi over 3, oh, we did this already, this pi over 3, pi over 6, 3 pi over 6, which reduces to pi over 2. And we have completed the B part. The dash, it is a cos graph. Where does cos graph start? At a maximum. The next ticking mark, it'll be at the center line. Next ticking mark, minimum. Next ticking mark, back at the center line. Next ticking mark, back at the maximum. Here is your dotted line. The dash is done. And finally, the shift. We need to go pi over 6 to the left. Can we label that? Yes, pi over 6 would be exactly 1 ticking mark to the left. Take each of our points. Move them 1 over.
I find this on the floor. Wait, yes.
Move this one over, move this one over. This is my final graph, put arrowheads on it to say that it continues, but I have graphed at least one period. If a question says graph at least one period and you didn't put arrowheads on it, you'd still get it right. If you did put arrowheads, you'd still get it right because you've done at least one. So it's really nice that way that I don't have to take off E9 errors. Okay? This is the final answer. We have done the shift. We've done everything in the DAB-C. If they asked you to go from negative 2 pi to 2 pi, because this is what they originally asked, my center line would still be at 2. I don't even think you should write this down. I just want you to watch and be annoyed. Feel for me as I'm doing this. You would still have your maximum at 2.25 and your minimum at 1.75. Your period would still be 2 pi over 3. Where is 2 pi over 3 on here? 2 pi over 3 would be a third of 2 pi. Does that make sense? So if I eyeball this, here's my 2 pi over 3. Then this would get divided into 4 equal sections. My graph up there is only here. Okay? I'm gonna make this 2 pi over 3 bigger. Another 2 pi over 3 would be, well, not that would be about there. 4 pi over 3. And another 2 pi over 3 would be perfectly this. A negative 2 pi over 3 would be here. Another 2 pi over 3 would be there. And each of these would have to be split up into 4 equal sections. And then I'd have to take my graph here and say, okay, I'm starting 1 ticking mark to the left at my maximum here. Then center line, then minimum, then center line, then maximum, then center. Back here, then minimum, then center line, then maximum, then center line, then minimum, then center line, then maximum, then center line, and do it all. See, are you annoyed? I'm annoyed. Center line, minimum, and center line. And if you put arrowheads on, you'd get an E9 because it said stop at negative 2 pi and end at 2 pi. That is annoying. So I will always ask you to do at least one period. But I have seen on some final exams, they give a domain that's ends, and then you have to end it there. Okay, questions you can circle. 3, 8, 9, 10, and 11. And 11, for a little star, make sure you factor on 11.